Hello guys, I'm Aadish Jain. You might have heard of me from Lemma 2024. Yes, that's the only place you should have heard of me. Anyway, yeah, I'm not really introducing myself. I'm just starting. Okay, so this will be the first lecture on inequalities. I will just heads up. I intend to cover like AMGM and Cauchy-Schwarz. Cauchy-Schwarz. Don't worry about the pronunciation. Just call it Cauchy-Schwarz. Yeah, and I'll just start. Okay. So the first thing, what did you miss? Bro, you missed nothing. It's fine. Yes. Okay, so first of all, this is the one inequality to rule them all, and this is also the only inequality, x squared greater than equal to 0. Most important inequality. Negative times negative is negative, positive sign. Wait, what did I say? Negative Aadish brothers intro. Bro, that was not an intro. That I was I missed it again. Good, because it was nothing. Anyway. This is really the only inequality there is. Any other inequality we have, it's basically just this with extra steps. Squares are non-negative. Okay. So, well, we'll okay, so since all squares are non-negative, well, x is real, by the way. In inequalities, we are only working with real numbers. And in fact, for most of the time, we are only working with positive real numbers. We don't complex numbers, you cannot have inequalities. It's not a thing. It's just don't worry about it. Okay. So we have x squared greater than equal to 0. Isn't Cauchy complex? What? We are sticking to normal Cauchy-Schwarz. Like, okay, sure, there is complex Cauchy. Okay, so since the square of any number is positive, the square of x minus y is also positive, but non-negative. Whenever I say positive, I mean non-negative. It's fine. So you can rewrite this as x square plus y square is greater than equal to 2xy, which you can rewrite as x square plus y square by 2 greater than equal to xy. And I'll just write this as x squared times y square square root. Okay. Uh, yeah. So this is true. Now, once I'll like do a change of variables, I'll like make x square as a and y square as b. So this also means that a and b have to be like greater than equal to 0. Right. So we get what happened till now. Nothing really. I just said x minus y square is positive and then I expanded it out. Yes, squares are positive. If you know squares are positive, you have not missed anything. So a plus b by 2 is greater than equal to root ab. So, so what is this? You add up two numbers and half them. This is their average. This is what we call their arithmetic average or arithmetic mean. So you add them up, you divide by 2. Well, divide by the number of things you're adding. And this is also an average, but in a different sense. So here you added them up and divided by 2. Here you multiplied them and took the square root. This is also like in some sense the average of the numbers, but this is called the geometric mean. Sure. Okay, someone's asking me about IM while at the end of the class I'll still. If you have any questions, you can ask at the end. Yes. So, well, this is our one inequality to rule them all. Well, okay, the inequality to rule them all is x squared greater than equal to 0. This is a close second. This is the AMGM inequality. The average of two numbers is greater than equal to, like, the arithmetic mean is greater than equal to their geometric mean. Is everyone with me so far?
Yes.
Can you explain the last step again? Wait, what last step? The average. Oh, I'm just like, when you want to take the average of a few numbers, are we doing the geometrical proof? I mean, that only works for two variables, right? Maybe I will. Okay. Yes. Okay. So it just means that, like, you have taken I mean, average is just, what is average? Why is it greater? Oh, why is it greater? Oh, greater, okay, wait. Because, uh, sp- yes. x minus y square is positive, and so x square, like expand this, x square plus y square is greater than equal to 2xy. You divide by 2. So x square plus y square by 2 is greater than equal to, I write xy as x square y square square root. And then I call x square as a and y square as b. But now a and b have to be non-negative. Right. Yeah, when you teach in a flow, it becomes like Chinese accent. I'll take that as a statement. Okay. I've never been called a Chinese accent. I have been called doesn't your no, okay, okay, no, it does not. Uh Even like the square of any number is positive, right? Like even the square of minus pi is positive. Like say like we wanted x squared to be 2, then we can just have like x to be root 2, right? It's fine. As long as it's like a positive number, you can find the square root, even if it's not an integer. Like square of non-integer is also positive. Okay, understood. Wait, the person who asked earlier, he also understood, right? Okay. Does everyone understand why this is true? A plus b by 2 greater than equal to root a. Yes. Okay. Very good. Now, the thing about this inequality is this y square of this inequality is actually can be generalized. So what do we have? We have taken two numbers and taken their average in two different ways. One by like adding them and halving, and one by multiplying and square rooting. Oh, I didn't finish. Wait. Yeah, after that, it's just you directly get that, right? You write y square as b, x square as a, and you directly get this result. Okay, Nikhil? Yes, okay. Yeah, it's fine, it's fine. You can just ask questions at any time. It's fine. Yes. So my claim is that this is also true in more generally. Like take three numbers, a plus b plus c. So this will be the arithmetic mean of the three numbers. So in general, arithmetic mean is like take all the numbers you have, add them up, divide by the number of numbers, right? This is the average of the quantities, the arithmetic, the mean. Oh, someone managed to find my Miro. And the geometric mean also in general, you multiply all the numbers you have, so a, b, c, and you take the third root because there are three numbers, you take the third root. Okay. I claim this is also true. Does anyone like just understand what I'm saying? I have not proven this yet. This is just a generalization of it. Yes. In fact, I would say the general AMGM actually states that take any number of numbers. So now I'm not no longer using letters, I'll use indices. So take A1 to AN, divide by N. This will be greater than equal to multiply A1, A2 all the way to AN and take their nth root. This is the general AMGM inequality that taking the average like by adding is always greater than taking the average by multiplying. I don't get why 3 came in RHS. Okay. Uh, so what we want this to be some sort of average, right? So since we are, suppose like we had three of the same numbers. So when you multiply, you will get a cube. So you want to take the third root to ensure you get a back, right? It's like the two. Yeah, I see what you mean. The reason there's a cube root here and not a square root is because like, oh no no, this is cube root. This is cube root. It's cube. Oh, okay, okay, okay. Don't mind my handwriting. Isn't Mick allowed? Mick is allowed. You guys can speak. I would prefer if you spoke. Yes. Also, okay, there are two conditions. There's okay, one condition on this that A1 to AN have to be positive numbers, like non-negative numbers. Same thing. Zero is positive. For the rest of this class, zero is positive. And the second thing is AMGM also states a stronger statement that not only is this inequality true, like let's go back. So we had this inequality. when are these two quantities equal? Right, like they are greater than equal to, when will they be equal?
When A equals
When,
B.
yes, they'll be equal when like this is actually in just 0, which happens when x equal y. Like the square of any non-zero number is just positive, only 0 squares to 0. So when x equal y and hence when a equal b. So AMGM in general states that like this quantity is greater than this quantity, and they are equal if and only if A1 equal A2 equal AN. This is the full general statement of AMGM.
Can you repeat again?
Okay. So the main like theorem I will prove in like the next whatever amount of time is that given any n positive real numbers, A1 to AN, you can take their average. So you add them up and divide by n. This is the arithmetic mean. Or you can take their geometric average, where you multiply them and take their nth root. Okay. AMGM states that this quantity is always greater than or equal to this quantity. And it also states they are equal only when all the numbers are equal. In other cases, they are unequal. It's just greater than. Equality cannot hold.
Oh, okay, okay, I got it.
Uh, does everyone understand what AMGM says? What is the second condition? Oh no, this is the only condition. This is the only condition. This is just another state, like an additional thing you get from AMGM. These two are like the theorems, and this is the condition, right? Uh,
Bhaiya, I have a
yes.
doubt.
Yeah, yeah.
But in the actual meaning of geometric progression, GM, I have
Hmm.
understood AM but not GM definition.
Wait, you don't understand what geometric mean is.
Just
Geometric mean is just defined like this. If you have like some numbers, say A1 to AN, then we say their geometric mean is you take their product and you take their nth root. So like if there are two numbers, you take their square root. If there are three numbers, you take their cube root. Gaurav, is it clear? Oh, you don't understand why it's called geometric.
just geometric mean.
Okay, okay. The reason it's called, okay, I mean, okay, I'll tell you why it's called geometric for two, and for more than two, I don't know. So I'll just write this here. Suppose you have, let me scroll down a bit. Suppose you have two numbers, A and B. So take like one line segment of length A and one line segment of length B and draw a circle with this diameter. Oh, this is not a circle. Okay. Assume this is a circle, and this is the diameter. You know what? I'll just draw a bit a circle. Oh, this is even worse. Anyway, so this length is root AB. And the proof for this is if you attended the power of point lecture, the well, I'll leave that as a homework if you attended the power of point lecture. But this is why it's called geometric means, because there's this nice geometric interpretation. In fact, and since like this chord is smaller than the diameter, and the diameter has length a plus b, so you get 2ab less than equal to a plus b. So this is like a geometric proof of two variable AMGM. This is why it's called geometric mean. For more than two, I don't really know of a geometric interpretation, to be honest.
Okay, bhai.
Did you understand?
Yes,
Yeah,
understood.
just anyway, like feel free to stop me if anything is like unclear or whatever. Okay, so now we have the inequality. How do we prove it? So the proof for two, we just like used squares. Now, theoretically, you can do the same thing for higher numbers. You just you like for like cube roots, like for example, for three variable AMGM, you cube both sides And then you can write this as like a sum of squares. Like I'll just do that actually. So you'll get, actually no, I won't do that. That's very annoying. We're gonna take bake into n segments. I don't think that works. It might. Anyway, yes. I'll just okay. Let's try to prove now. All attended the induction lecture, so you would think I'll try to go from 2 to 3 to 4 to 5 and so on, right? That's how you induct, and I will prove AMGM by induction. But I will instead go from 2 to 4 and then back to 3, and then from 4 to 8 and then back to 7 and then to 6. So this is a very weird form of induction, as you can see.
Why? Can you tell why?
Because it's easier. Okay. First, let's just try to prove AMGM for 4 variables. Like I claim that it's easier to prove it for 4 variables than it is to prove it for 3. So what do you want to prove? You want to prove a plus b plus c plus d by 4 is greater than equal to abcd to the 1 by 4. You're right. So you can write this as a plus b by 2 plus c plus d by 2 by 2, right? Yeah. And a plus b by 2 is we already know AMGM for 2 variables. So we know a plus b by 2 will be greater than equal to root ab. And we know c plus d by 2 will be greater than equal to root cd. Right.
Yes.
So a plus b plus c plus d by 4 will be greater than equal to root ab plus root cd by 2. Right. And now, this is the arithmetic mean of root ab and root cd. So this will be greater than equal to the product of root ab and root cd, the square root of that, which is just equal to AB German accent. Yes, a new accent. Just figure out all the accents I speak, guys. And that's greater than equal to. Okay. Is this proof?
What did
I don't understand.
What did you?
Okay, wait.
There.
Okay, let's go one by one. Does everyone understand this step? Why is a plus b plus c plus d by 4 greater than equal to root ab plus root cd by 2?
Yeah.
Okay, like, if you understand, it's fine. Like, if someone doesn't understand, just speak up or type in chat. How did the RHS come in that step? Okay, okay. So we already know a plus b by 2 is greater than equal to root ab, right? And c plus d by 2 is greater than equal to root cd. This we have proven already. Now we add up both of these. We add both the inequalities. Because like if this is greater than this and this is greater than this, then their sum is greater than this sum. And this is greater than equal to root ab plus root cd. And then you divide both sides by 2. So you get this. Nikhil, is it clear? Yes. And now, as we did, once again, we have the average of 2 numbers. So that's greater than the square root of their product, which is just ABCD to the 1 by 4. Okay? Yeah. And well, you also have to check that like this is true, that the equality holds if and only if all the numbers are equal. And that's because like if this thing, if the arithmetic mean is equal to the geometric mean, then all of these in the middle are also equal to them, right? Like if equality holds here, then it has to hold in all the middle steps. And for equality to hold in this step, A has to be equal to B because we use normal AMGM here. And C has to be equal to D. And for equality to hold in this step, AB has to be equal, root AB has to be equal to root CD. So you just get A, B, C, and D all have to be equal.
It's so as you use AMGM for numbers, as you increase the value of n, does the
What? Hmm.
hearing me, right? So does the quote unquote strongness of the inequality decrease?
I mean, I won't say just like strongness is a very relative term. I won't say it like decrease. Does it? I won't say so. Like depends on what you mean by strongness.
Strongness meaning here we just showed AMGM for 4 variables by using AMGM for 2 and then
Yeah.
getting a term in between. So
Yes.
some sense this is a weaker inequality than AMGM for 2 variables, right?
Fair enough, I would say, but I don't get how you raise. Okay, I'll get to that. Yeah, but I think that's just because there are like more variables. So like for normal AMGM, the only way for it to break is if A and B are distinct. And for here, there's like 6 different ways this can break. A and C are distinct, A and B are distinct, B and D are distinct, D and C are distinct. So I guess in that sense, it's like a loser inequality. Although I find like comparing like a 2 variable and a 3 variable inequality in terms of looseness is slightly weird. That's just, I mean, you can definitely say it in some sense. Does it hold for true for real numbers which are not whole numbers? Yes. It holds true for any positive real numbers. Like, because the thing is, everything stems from this fact that squares are positive. And the square of any number, even if it's not a whole number, is positive. Arabian accent. Very good, very good. Keep going. Okay. Does that answer your doubt, Leonard? Leonard Euler. Oh, very good. We have Euler in the class. Okay, and Nikhil. Yes. So here, do you get this step? By root, like, do you get till here? Root AB plus root CD by 2 is greater than equal to root of root AB times root CD.
No, I don't get from our root AB plus root CD
Okay.
to whole root
Okay.
of a root AB.
Okay, so
Yes.
this part is clear, right? A plus B plus C
Yes.
plus D by ah. So now we apply AMGM again. So AMGM states that for any 2 positive numbers, we have this. And we apply AMGM for x equal to root AB and y equal to root CD.
Okay.
Okay. So what do you get?
Okay, I got it.
Yes. And this is just root ABC. Yes.
Also,
Okay.
why are the numbers equal? Uh,
Huh.
all the numbers used are equal. You said it here.
Okay.
Yeah.
Okay. So we have what? We have like A. Let me just write the whole chain. A plus B plus C plus D. No. Okay. This is the whole chain of inequalities. Now suppose that A plus B plus C plus D by 4 is equal to fourth root of ABCD. Right. Now, if these two are equal, then this quantity, which is like in the middle of both of them, also has to be equal to both of them. Right. Now, from here to here, we used AMGM on AB and CD. We know that if A and we know that AMGM like has its equality case when A and B are same and when C and D are same. Like okay, AMGM has its inequality case when A and B are same, right? So if these two things are equal, then A and B have to be equal because we have used AMGM on A and B, and C and D are equal because we have used AMGM on C and D. Because if C and D were not equal, then C plus D would be strictly greater, like C plus D by 2 would be strictly greater than root CD. And this will not be, equality would not be able to hold here.
What is AMGM equality?
Oh, okay. Wait, let me rewind. Okay. I'll just recap a bit. We had this inequality. This was AMGM for two variables, right?
Yeah.
So the thing is, Aadish premium, I like that. So if A and B are unequal, then we have this. Then there's no equality here. It is always greater than. And if A and B are equal, these are the two cases of AMGM. Okay.
Okay.
Yes. Now, I want to find like we have proven that A plus C plus D by 4 is greater than equal to A, B, C, D to the 1 by 4. Right. I want to find
Yeah.
out when these are in fact just equal. Okay. Now, go back to the proof. Our proof was in like two steps.
Yeah.
We first prove A plus C plus D by 4 is greater than equal to this thing. And then we prove this thing is greater than equal to 4th root of ABCD. Right.
Right.
So if we want to find out when these two things are equal, for these two things to be equal, the thing in the middle also has to be equal to them, right?
Yeah, right.
What's
So
in the middle?
what?
Yeah. Can you repeat the statement?
Okay. We have. Wait, I'll call this thing like capital X. This thing as capital Y. This thing as capital Z. So what we have is we have proven X greater than equal to Y greater than equal to Z, right? And I want to find when X equals Z. Okay.
Okay.
So if X equals Z, and we know y is like smaller than or equal to X, and y is greater than or equal to Z, and Z is also X. So y lies between X and X, right?
Yeah.
So y just has to be X again.
Yeah. Okay.
So now
Got
go back to y greater than equal to Z. So y was root AB plus root CD by 2 greater than equal to root AB root CD. This was that. Hmm. And so we know that these two are just equal, right?
Yeah.
So once again, this was AMGM for two variables. And we know from here that if these two numbers are equal, like this is 2A. If these two numbers are equal, then like the two things we are applying AMGM on have to be equal, right?
Mhm.
If the two like if AM is you're stuck on four numbers from 20. I mean, I have to clear everyone's doubts first, right?
I think I got it. You can.
I mean, it's fine. It's fine. You don't have to. Do you understand now?
Yeah.
It's. I mean, you can ask me after class if you want.
Okay.
Anyway, okay. So this is how you prove for four numbers. I'll okay. I'll put this in the P set. Use the same argument to go from 4 to 8, and just prove it by induction for all 2 to the k. Okay. So this will give you AMGM for. How can we talk after class? Bro, just DM me on Discord. Okay, 2, 4, 8, 16. And okay, Now how, like, we have proven it for all powers of 2, assume, right? Now how do we prove it for all the numbers that are left? When do two things equal once again, please? Like, okay, I'll just say it right now. Just will have to like move on to other stuff. Okay. AMGM, these two are equal if and only if A, B, C, D all are equal. Or like how many numbers there are, they are all equal. Okay. Yes.
Bhaiya, I have a doubt.
Yeah.
Is A plus B plus C D plus D upon 4 always be greater? Can it be lesser than root?
No, no, it cannot be.
Okay.
That is the entire statement of AMGM. It can never be less. Okay.
Okay.
Okay, I'll just okay, so now let's do something. Suppose we have AMGM for 4 numbers. Apply it on A, B, C, and A plus B plus C by 3, and tell me what you get.
Indexing on K, like K plus 1. Uh, how can we take like 2, 4, 8 instead of n plus
Oh,
1?
you're inducting on the power. Like you're proving like your 2 is 2 to the 1, 4 is 2 to the 2,
Yeah.
8 is 2 to the 3. So you're inducting on the power. So from 1 to 2 to 3 to 4.
Okay.
Just wait, give me a second. My laptop is about to discharge. Do what I try this. Like apply AMGM for 4 variables on A, B, C, and A plus B plus C by B. Did you guys try it? What do you get after you apply AMGM on these? Just say it. Wait, can you guys hear me? Okay.
Yeah.
No, it's fine. I'll take a few minutes and tell me what you get after this.
I have a plus b plus c over 3 is greater than or equal to the fourth root of abc multiplied by a plus b plus c over 3. Is that
Can you
correct?
repeat? Can you repeat it?
Yeah, the
A.
third arithmetic mean a plus b plus c over 3 has to be
Hmm.
greater than or equal to the fourth root of
Yes, yes,
a
yes.
b into c into a plus b plus c over 3.
Yes, this is correct. But you can simplify it further.
I can square it, I guess.
No, don't square it. Uh, like you have same terms here. Cancel them.
What sense is the square aside
Okay, you
the
can
a
actually
plus
just
b
square.
plus?
Actually, take fourth powers. Just take the fourth power.
All right, yeah, I got it. A plus b plus c over 3 whole power 3 has to be greater than or equal to abc. This is the statement.
Yes. U A plus B plus C, and like Like you get 4 is greater than or equal to ABC, and like you cancel 1, and then you can take like power 1/3 again, and then you what do you get? Have you seen this before?
Yes, I think I saw this before in a handout.
Yes, and
Now I
also
have a doubt.
yeah,
Like we use power of 2's here, 2 into 4
yeah.
into 1, and prove it for an minus 1. So that
What
results in
prove it for
induction. Like
prove it
what
for
we
what?
did here is we powered it for powers of 2,
Yes,
then we proved it for n minus 1.
yes,
So that works. So can we do the same thing with power of 3 or power of 4 or power of
yeah.
n? Hmm.
The point is, you like suppose you prove it for some like very large number, capital N,
Yes.
and then you can prove if you prove it for capital N minus 1, then you can prove it for capital N minus 2, and then you can get every number that is smaller than n.
Okay, so
So
it's
you
a
just
chain, but it's a backwards chain. First we go forwards, then we go
yes,
backwards, instead of
you
just.
just have to go like as long as you can go as far forward as you want, you're done. And like the point is, 2 to the large number, like 2 to the n, you can make this as large as you want.
Okay.
Just okay, wait. But by the way, is everyone clear how like putting this just gives you AMGM for 3 variables? Yeah, this is literally Cauchy induction. This is what's called like. Can you please do it? Do what? Put okay. Uh, yeah, it's like when you put it, you get a plus b plus c plus a plus b plus c by 3 whole divided by 4, which simplifies to this is greater than or equal to, the product by fourth power, like fourth root. You take fourth power on both sides, and then you cancel a plus b plus c by 3, and then you take the cube root on both sides, and you get this, right? And this is AMGM for 3 variables. Okay. So in general, now I'll just assign this as a homework. This will put this on the P set. Number 1, we prove AMGM for 2 variables. Then we induct 2 to the k variable, like 2 to the k for any k. And then finally, we induct down from n to n minus 1. And this proves AMGM for everything.
So I would like the way we went from n to n minus 1, can't we just smoother the whole thing, go from n minus 1 to n?
No, because the thing is, we used a very specific case for 4 variables, a, b, c, and a plus b plus c by 3. If we do this in reverse, we will never be able to get general ABC, like A, B, C, and D. Like just doing this proof in reverse. There might be other ways to induct, but if you just try to do this in reverse, you will get this special case of 4 variables, not the entirety of 4 variables.
Okay. Yes, me.
Okay,
Yes.
makes sense. Very good.
Shouldn't we add all the 4 elements in the LHS?
What?
There's only a plus b plus c by 3, but the a, b, c are still there.
No. Okay, this is let's skip some calculation. This is a plus b plus c plus a plus b plus c by 3 by 4. But you can take a plus b plus c common, and this will become a plus b plus c times 1 plus 1 by 3 divided by 4, which is 4 by 3 by 4, which is just 1 by 3. Okay?
How is that possible? Like, we are adding something to a plus b plus c by 3, and we are getting same a
No,
plus b
but we are
plus
not
c
just
by 3.
adding, right? We are also dividing.
Oh, okay, okay.
We also divide by 4. And so we get the same thing back.
Okay.
Good. Okay. Now let's move on to some problems. Wait, let me get some let me see which problems to do. You know, I'll just paste this whole photo and we'll see how many we can. Fully understood. Very well. For those of you who haven't understood, I'll just like put like proving AMGM in general in the piece set because I have not covered the whole proof. I have just covered like 4 and 3 and 2.
Yeah,
And
can
if
you
anyone
share
has,
the formal proof of it?
this is formal.
Yeah, like the proof and very detailed steps.
Yeah, that will be in the pset solutions. Like put the proof as a problem in pset, and you can try to like get the whole proof yourself. And then the next pset, when we have the solutions, I'll put the full solution. You can read it if you don't understand.
Okay.
Nesbit is a solution. No, Nesbit, you can. Okay. Okay. First of all, do P2. P2 here is the CB. Don't ask me those kinds of questions. I don't know. It's the anyway. Uh, okay. For every first do P2. This is like the easiest of them. Then P3, and well, then we'll see. You do you like eating dogs? What kind of DMs are these? Anyway, so and if anyone's like done with 2 or 3, just DM me how you did it. I'll like wait for a few minutes sometime for everyone to try.
What to solve problem 2?
Problem first do problem 2, then do problem 3. Okay.
Actually, I had a question, not
Yeah.
regarding this, but for
Mhm.
rearrangement inequality, does the
Mhm.
rearrangement inequality all work if the numbers are negative also?
Does right? I think it does.
Like, how would you prove that? Because
First question not visible. I mean, I think the standard proof just works, although not quite sure. I think this normal proof should work. Hmm. Actually, maybe not. Rearrangement inequality, I mean, you can ask me after class. I'll, yes, answer the DMs.
okay,
Okay, so, okay, I'll, I'll just start with, some people are done with, yes, okay. Yeah, okay, multiple people are done with, okay, if you're done with like 2 and 3, try 4. Or try 1. I mean, it doesn't matter. You can try whatever you want. Anyway, I'll discuss. Multiple people seem to be done with 2. I'll discuss the proof for 2. Okay. So what you whenever you see an inequality, like the thing with this is you have to prove some weird sum is bigger than 4, right? That's what you have to prove. This one is 52. Okay. Okay. For the first inequality has like hundreds of proofs. Okay, no, maybe 100 is exaggeration, but like find an AMGM proof. I mean, doesn't matter actually. Find whatever proof you like. Yes. Back to this. So when to apply AMGM? So you have the sum of 4 numbers, and you want to prove it's greater than equal to 4. And the sum is like you have no idea how to do this. But the product of these 4 numbers is like really simple, right? Because if you multiply these numbers, then B cancels, C cancels, D cancels, A cancels, right? So when when there's numbers like this, whose product is very nice, you want to use AMGM. So apply AMGM on these four numbers. What does that tell you? All done, all done. Good, good. 5, 4 greater than equal to 5. All done. Okay. And does everyone see how 2 is done? This is just 2. Multiply by 4, and this side is just 1. Multiple people are done with it. Okay, I'll post some more problems for the people who are done with everything. But till then, is everyone clear with 2? If anyone has any doubts in 2, just say. Will it be 16 or just that's this. If people who are done with everything can try this. Yeah, anyway, does anyone have any doubts in 2? All done, all done. No? Okay. Okay, for 3 also, it's just AMGM. 3, what you do is we are given a condition on the product, right? So you want to be able to, well, use the condition somehow. So you want the product. Yes. So what you do is you apply AMGM on each of the terms individually. So we have right, right. And you apply it on all of them and you multiply them out. So you get 1 plus A times 1 plus B plus 1 plus C times 1 plus D is greater than equal to 16 times root A, B, C, D. Right? And that gives you C. Is everyone clear with 3 also? This
Can you repeat P3?
P3, what you do is what you want is you want to somehow introduce the product, right?
Yes.
You want A, B, C, D. So you have 1 plus A. If there was only a term with A in here, it would be nice. You want to get rid of the 1. So once again, like you want the product of 1 and A, not the sum of 1 and A. So you use AMGM on 1 and A. So 1 plus A is greater than equal to 2 root A. That's AMGM. Right. And then you multiply it out. Like 1 plus B is greater than equal to 2 root B. 1 plus C is greater than equal to 2 root C. 1 plus D is greater than equal to 2 root D. You multiply it out and you get like the product greater than equal to 16 times square root ABCD. And ABCD is just 1, so we are done. Is that clear, Gaurav?
Yes.
On ABCD, then that is abused. Wait, no. With which problem are you talking about, Euler? Yes. Yes, people have found the for P2. But A, B, C, D. No, 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 no. In P2, use AMGM on the ratios. Like use AMGM on A by B, B by C, C by D, and D by A instead of using them on A, B, C, and D. That's three. Three AMGM in A, B, C, D. Uh, that will not. You're only using AMGM on A, B, C, D, and 4. That will not work. Yeah, I don't think what you have said works. I mean, you can like write it up properly and send me, but I don't think that works. Anyway, I'll come to 4. Like 2 and 3 are just you apply AMGM on, you just find which quantity to apply AMGM on. 4 requires some more effort. So for 4, I'll introduce this very important technique called homogenizing. Uh, Okay, so
That
suppose you want to prove something by AMGM. Suppose you like have a bunch of terms that you apply. Like what I should say. Okay,
Bhaiya, what did you write here?
this is homogenizing, homogenization. Like this is a very important technique which we'll talk about for P4. So the point is, suppose you have A plus B plus like no, A square plus B square plus 2AB plus CD, and you want to prove it's greater than equal to A or something, like some inequality like this. And suppose you like try to apply AMGM on this side, this will never work. Why will this never work? Well, because every single term on this side is like degree 2. There are two variables multiplied together. A and A, B and B, A and B, no, like it's degree 2, like the sum of like all the powers is 2. So A to the 1, B to the 1, C to the 1, D to the 1. And when you multiply, like apply AMGM, you the degree, if the degrees are all same, the result will also have the same degree. Like if you have like x plus y plus z by 3 greater than equal to x, y, z to the 1 by 3, then x, y, z, they are all like, say, some degree, say 5. Then x, y, z will have degree 15, and its 1/3 root will have degree 5 again. Right.
Yeah.
Yeah, right.
So similarly here, like in this kind of inequality, you have degree 2 terms here. If you apply any sort of AMGM, you will end up with a degree 2 term, and you have a degree 1 term on this side. So this is like sort of hopeless to try to prove by AMGM. So let's get back to P4. So in general, what you want, if you want to prove an inequality by AMGM, you want to be able to make it all like same degree. Like that's what we have been doing. That's what we actually did in P3. In P3, we had like 1 and A, which are terms of distinct degree, and like 1 and B terms of distinct degree. Those we made same like simply by just applying AMGM. Like you apply AMGM on terms of unequal degree, and you get like a term of some other degree. Right. For P4, it's not that simple. Okay. Here's what we'll do first. So let me just write P4 here. P1. I've already said the answer in chat, which is correct, but don't spoil. Okay. So the issue here in this inequality is, as I said, we want our inequalities that everything is of the same degree. And here, things are of different degrees. Like this is one, and this is not one. Like this is like constant, and this is degree one, and this is constant. This is degree one. So that's an issue. How do we fix this issue?
What's the
Well,
issue?
okay. So like this is like a more a heuristic thing. Like whenever you want to try to use AMGM, it is very nice if every single term you are working with has the same degree. Because like as I said, if terms have different degree, then they usually are like hard to do by AMGM. Like because if you apply AMGM on terms of the same degree, you get the term of the same degree. Okay.
Okay.
So one is like you can think of one as a to the zero, right? That's a 0 degree term. And a is a 1 degree term. So these are different degree terms. So like this is not good for us. We would prefer if all the terms were same degree. A degree, no, degree LHS is not added. Like the degree this is not defined here because there's a term of degree one and a term of degree zero. When you expand it, there will be some terms of degree three, some terms of degree two, some of degree one, some of degree zero. We would ideally want all terms to be degree three or all terms to be degree one or just everything to be the same degree. Okay.
Okay.
This is just a this is just like this isn't anything formal. Like you can prove inequalities without everything being the same degree. It is just a nice like whenever you have faced with inequality, it's often nice to try to make everything the same degree. It will like usually make the inequality simpler. Okay. So do you understand like we want to make the all everything same degree? That's what we want right now. Because like there is no clear way to apply AMGM. Like in problem 2 and 3, you just apply AMGM once and you're done. In problem 4, there is no instantly clear way. So we try to use some more like heuristics. Yes, yes, precisely, Leonard Euler. Okay, now we do have this condition with us. A plus B plus C equal to 1. Can you use this condition to somehow make this into like homogeneous? Everything having the same degree. Yes. Okay, I'll tell you. You can. So you have, say, you have A plus 1. And the issue is that 1 is constant and A is linear. But we know 1 is equal to A plus B plus C, right? So we just replace 1 by A plus B plus C. You get A plus B plus C times, and you replace 1 everywhere by A plus B plus C. So you will get 2A plus B plus C times 2B plus A plus C times 2C plus A plus B here. And you want to prove this is greater than equal to, well, you replace 1 by A plus B plus C here. You get this, correct? If you replace 1 by A plus B plus C. And now it's homogeneous. Is everyone clear with what I have done?
Yeah.
Yes. Okay. So this is the like first sort of like advanced, not advanced, but like Inequalities are more than just like applying AMGM or Cauchy-Schwarz or like some other things. Some terms.
Bhaiya, can you repeat what did you do after the degree?
We know, like the question tells us that A plus B plus C is 1, right?
Yep, right.
So wherever I have 1 in here, like 1 here, 1 here, 1 here, I replace it by A plus B plus C. Okay? Because 1 is just A plus B plus C. And when I just write down what I get this. Like I have to prove this. I have still not proven this, but it suffices to prove this. Okay?
Okay.
Yes. So this is the like first thing you should keep in mind when you're doing inequalities. You should use like if a problem gives you some condition like A plus B plus C equal 1 or something else, you should try to put this in the inequality given to make it homogeneous. That will usually make your life easier. So just homogenize like in all caps. This is just something you want to do. Okay, I won't write any. My handwriting sucks. Okay. Now the second thing you want to do is change variables. So here it's still like very unclear what you want to do. Like this is still a very weird inequality. We have no idea how to try to prove this, right? But
Yes.
if you notice carefully that like there is no like instance of like A, B, and C alone, right? Every time they're like added together, A plus B, A plus C, B plus C, or whatever. So if you just say like B plus C is X, no, yeah, B plus C is X, A plus C is Y, and A plus B is Z, then you also notice what is 2A plus B plus C? It is A plus B plus A plus C, right? So this is just Y plus Z, okay? Similarly, this is X plus Z, and this is X plus Y, okay? So X plus Y times Y plus Z times X plus Z. It suffices to prove this, right? Does, does everyone see that? Why does it suffice to prove this?
Can you say the inequality?
What? Can you repeat? I didn't hear you.
Nothing.
Yeah. Yes, exactly. So this is the second lesson. If ever you see like a lot of weird terms, change your variables to something that's nicer. Like B plus C, A plus C, A plus B. These are just like nicer things to work with because the inequality now looks much cleaner. Right. And now this is just AMGM. I'll leave it as an exercise for you to see how AMGM finishes. Yes, exactly. People already see it. So sometimes, like, whenever you see an inequality which you like don't immediately like see how to do or whatever, first homogenize, try to homogenize. That will make our lives easier. Sometimes that's just enough. And second, um, what did I just say? Yeah, make substitutions, change variables.
Uh, I am
Okay.
also thinking about it that we can substitute also the value of
Hmm.
B, B and A from A plus B plus C. We will get the value of B equal to 1 minus A minus C.
Yes, you
Can we
can
do
do
that?
that. You can do that. That is also like a method. Like you just get rid of one of the variables. Although in inequalities, that's usually not something you want to do. Like sometimes it works, but in general, like thing is, it will just make your inequality much messier in terms of a and like it. Sure, you'll just have two variables left, but they will be like much more messy. And like the nice thing about this inequality is it's completely symmetric, right? So you want to be able to like use that symmetry because AMGM is also like a very symmetric inequality. There is nothing different about A, B, and C, right?
So what's the better method to approach problem?
Symmetric. This one is but I mean, like usually you don't want to like get like sometimes that's fine, and as you can like do more problems, you will figure out when you want to get rid of a variable. But usually in inequalities, it makes sense to like keep the symmetry of the problem. If the problem is symmetric, just keep it symmetric. Don't try to get rid of a variable in general. Okay, is that clear?
Okay.
Now I also want to okay. P1 we can also do out of after we are done with Cauchy-Schwarz. P1 I'll leave for now, or you can I'll try this one. Just introducing the idea of weights for a bit. This might be a little bit hard. Okay, okay, let's go. So we want to prove a to the 7 plus b to the 7 plus c to the 7 is greater than equal. Sorry. We cannot myriad this. For those of you who don't know what myriad is, don't worry about it. And for those of you who know, this is cyclic. This is not symmetric. You cannot use myriad. Okay. So we have this inequality. And the sad thing here is, as you can see, like, wait, actually, before this, let's just go with this. Yeah. So the issue is now A and B here have different powers. This is A to the 4 B cube, B to the 4 C cube, C to the 4 A cube. And like, which is weird because usually when you use AMGM, you like, you should everything has the same power, right? Like, like if you use AMGM on say A, B, and C, then A and B both will have a power of 1 by 3. But we somehow want them to have different powers here, right? So how can we approach this? Do you see the like issue why like it's sort of weird to apply AMGM directly? Looks rearrangement. It is not rearrangement. Well, okay, actually, can you can do it by rearrangement.
It's breaking
Just-
down.
What?
It's breaking down to
Yeah,
solve.
you can do it by rearrangement. But let's go with the AMGM proof. You can actually. Oh yeah, breaking.
Any
I see what you said. Come on,
any
go ahead.
hint?
Okay. Actually, I'll just give a hint. Yes. So in general, say yeah. Okay, someone already said the answer in chat. It's fine. So when you like directly use AMGM, you will get like 3 times a to the 1 by 3, b to the 1 by 3, c to the 1 by 3. The thing is, you don't have to use AMGM on different numbers. You can also use AMGM like this. A plus b is greater than equal to 3 times a to the 2 by 3, b to the 1 by 3. Like this is also valid AMGM, and this allows you to have a and b as different powers, right?
How did it become a to the power 2?
What?
Oh, okay. Okay.
Yeah, people in chat already see it. So here you want a to the 4 times b cube, right? So like think like this idea. How can you get a to the 4 times b cube? Yeah, okay, people in chat have already said the answer. I'll just wait for like 2 more minutes. Okay, sure. People in chat have some people in chat have already done it. I'll just okay. So what do you want? We want 4 powers of A and 3 powers of B, right? As we just saw, like when you take 2 copies of A and 1 copy of B, you get like B to the power A to the power 2, well, by 3, and B to the power 1. So if you want 4 copies of A and 3 copies of B, just like take them. A plus A, that's just a bit, that's fine. Plus B plus B plus B by 7. So this is, we are taking the 7, we are applying AMGM for 7 variables on A, B, B, B. This will be greater than A to the 1, A times A times A times A times B times B times B to the 1 by 7. Correct? So you will get 4A plus 3B by 7 is greater than equal to A to the 4 by 7 times B to the 3 by 7. Right. Is everyone clear with why this is true? Yeah, okay. And you can also apply this. Like in our problem, we don't have A and B, we just have A to the 7 and B to the 7. So actually just apply it on them. So we in fact have 4A to the 7 plus 3B to the 7 by 7 is greater than equal to A to the 4 B cube. Correct? Similarly. Right? Is everyone clear with the 3 statements? Yeah. Hello, I can't hear you. Can you repeat?
For I don't get this part where you remove the.
I don't know. I just like I did this inequality for A and B. Like do the same thing, but for A to the 7, like A to the 7 plus 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 B to the 7 plus B to the 7 plus B to the 7 by 7 is greater than equal to, like just apply this inequality, but for A to the 7 and B to the 7 instead of A and B. Okay.
Okay, I got it.
And similarly do it for B and C and A and add up the 3 equations and guess what you get. You get this. Is everyone clear with what I have done? HP. What is that Harry Potter? What? Help, please. Guys, what does health points? What does HP mean? Harmonic progression. Oh, hence proof. Oh, Harry Potter. Yeah. Oh, hence proof. Use QED. Please use QED. Okay. Okay. So basically I wanted to like through these problems cover 3 ideas. Number 1, homogenization. Number 2, substitution. And number 3, um, weights. Weights is basically you apply AMGM on 2 variables, but unequally. You take multiple copies of A and like multiple copies of B and like different amounts so that you can get a different result. Does everyone understand what these 3 ideas are? Because like I feel like knowing these ideas are more important than like knowing specific inequalities like AMGM, I whatever, Cauchy-Schwarz, Cauchy-Schwarz. Yes. I think so. Harmonic progression. Who uses harmonic progressions these days, guys? Harmonic progressions are so last generation. Yes, ideas are very important. Okay, very good. What is second and third? What is second and third? Substitution. Substitution is just like whenever you have a weird looking inequality, like instead of using A, B, C as your variables, you make new variables. Like B plus, like here we did B plus C we replaced by X, A plus C by Y, A plus C by Z. And weights is this. Weights is what we just did. Like when you want to get some sort of like weird thing like a to the 4 b cube, you apply AMGM on A and B, but you apply it unequally. You take multiple copies of A and you take like multiple copies of B. Like four, here we took A to the 7 4 times and B to the 7 3 times before applying AMGM. Right. Why is it called weights? Like look at the like the point, like look at this inequality 4a to the 7 plus 3b to the 7. The idea is like it's look up weighted. I mean, why is it called weights is not really something you can get right. It's like the idea is that a to the 7 you're giving more weight to. You're multiplying it 4 times, and b to the 7 you're giving like less importance. You only multiply it 3 times. But like the names don't matter. That's fine. Yeah. And as some people have like suggested, like you can just generalize this to weighted AMGM, which like you don't really have to. You can like always just do these kinds of things. Although this is you can just learn the result also. Probably put that in the P set. Okay. Now, while as I said, ideas are important, I will actually cover one more inequality before we end. Like, okay, AMG Cauchy-Schwarz or Cauchy-Schwarz or I don't know. Okay, guys, what does CS stand for? Wrong answers only. Computer science. Okay. So here's an inequality for you. Okay, first off, why I don't say it like this. Okay, I'll just write the inequalities. A1 square plus cats. How does it stand for cats? Square plus A2 square. Cubes and squares. That's actually nice. I mean, Cauchy-Schwarz only has squares. There are no cubes. This this is the inequality, which looks weird. I know. Cunning squares. This is sure. And actually, cunning squares. I'll believe that.
Uh, is that a square in the RHS?
What?
Is
There's a
that a
square. This is
square? Yeah, yeah.
yes. This is squared. There's a
Oh,
looks
okay.
good. Okay. First of all, I'll give you one intuition to like remember this inequality and see what this is. Although this does require you having okay seen vectors before. If you don't know what vectors are, don't worry about it. Okay. So suppose you have two vectors v1 and v2. Then we know v1 dot v2 is equal to mod v1 times mod v2 times cos theta, where cos of the angle between them, right? Square both sides. v1 dot v2 square equal to v1 square v2 square cos square theta. And we know cosine is like always less than equal to 1. So this is less than equal to v1 square times v2 square. Okay. So we have v1 dot v2 square less than equal to v1 square v2 square. So if suppose v1 was like ai cap plus bj plus a1 I cap plus a2 j cap plus a3 k cap, then v1 square would be a1 square plus a2 square plus a3 square. Similarly, if V2 was B1 I cap plus B2 J cap plus B2 K cap, it would be B1 square plus B2 square plus B3 square. And V1 dot V2 will be A1 B1 plus A2 B2 plus A3 B3. The people who know what vectors are, that makes sense. Yes, like in general, that's n-dimensional vector. Amazing. No. Okay. This is not an amazing proof because I have not proven this fact. Like, this is technically a cyclic proof. For like general n-dimensional vectors, you define the angle between them using this equation. And like, you cannot imagine an angle in 4D. You have to define it through the algebra. So this actually does not count as a proof. You actually have to prove Cauchy-Schwarz some other way and use it to prove the angle makes sense. This is actually not a proof, unfortunately. But this is a very like slick way of understanding why this is true in some sense. Okay. Okay, people who know what vectors are, does it make sense still? Like, is the inequality sign correct in the last line? Yes, okay. Cauchy for complex is wait. No, the thing is cosine is less than 1, right? So like this thing is less than equal to, well, this times 1. Right, cosine square less than equal to 1. Explain once again. Okay, so like we just use the fact. How is it greater? So it will be square. Yeah, so that's what I've done. Cosine square, this is less than equal to. Cosine square less than equal to 1. I don't know. Cauchy-Schwarz for complex numbers is like different. I will not be covering this. That don't don't worry about it. Cauchy-Schwarz has like a big generalization. Yeah, this is for understanding. This is for understanding. This isn't a proof. I'll give a proof. What is on the LHS? Like, if you don't know vectors, don't worry about this. This is all vectors. This is a dot product. In the last line, LHS V1 dot V2 squared. The dot product of two vectors squared. Anyway, here is the chill proof of Cauchy-Schwarz, which in my opinion is like pretty magical. I don't know how anyone came up with this. Consider this quadratic equation. Consider this quadratic, like this is a quadratic equation, correct? When multiplying with less than 1, there, that's the point. That's why there's a less than equal to. Anyway, I'll come back to you later. Think about it. Yeah, so we have a sum of squares. Now, this quadratic equation, since it's a sum of squares, that says it does not. It literally says it's less than equal to. Less than equal to. Man. Anyway, yeah. Back to this. Let's not get distracted. Okay. So this is a quadratic equation. Now this is a sum of squares. So it can never be negative, right? This quadratic equation can never be negative. So that means its discriminant has to be greater than equal to 0.
Yes.
Like this. So what is its discriminant? So what's the coefficient of x in this? Like x, if you expand this out, you'll get summation like ai square times x square minus 2 times summation ai bi times x plus summation bi square. Right? This quadratic equation, this is the quadratic equation, right?
Yes.
And its discriminant, as we said, since it's a sum of squares, it can never be negative. Its discriminant has to be positive. So if you compute the discriminant, that's b square.
Shouldn't it be negative?
No, there is a solution.
I
So
apologize. I apologize. I apologize. It should be negative. Yeah. I will
Oh,
say
yeah.
that I will say I was testing you. Trust. Trust. So this is b square. So 4 times summation ai bi square minus 4ac summation ai square summation bi square less than equal to 0. And you can divide by 4 and take it to the other side, and you get summation ai bi square less than equal to which is Cauchy-Schwarz. Does everyone see that? This is by no means an easy proof. It's, in fact, I feel this is like pretty magical. Can you say again? Okay, wait, just give me this. Yeah, what was I saying? So you have this quadratic equation. This quadratic equation is never like negative. So like if you draw a graph, that's some small equations. Yeah, always do small cases. The graph of this quadratic equation, like it either just the x-axis or it is just like better. It's just above it. So the discriminant has to be negative because discriminant is positive when it has a double root, which is if it had like 2 roots, the graph would be negative somewhere. Give us a problem. Okay, I'll give you a problem, but just a second. Okay. In fact, okay, I'll just also say once again, when does equality hold? Well, when discriminant is 0, right? And discriminant is 0 when like this equation has a root, right? For this equation to have a root, all these squares have to be 0 together, right? So x has to be equal to b1 by a1. X also has to be equal to b2 by a2. X has to be equal to all of them, right? Every single thing has to be 0. So b1 by a1 equal b2 by a2 equal b3 by a3 and so on. This is when equality holds. Okay? Right. I'm just saying like, so this is like, just like AMGM holds when everything is equal, Cauchy-Schwarz holds when this happens. Okay, but I'll like, here we notice something. Never in this proof did we use the fact that A and B are positive. Cauchy-Schwarz holds for all real numbers, not just for positives. Cauchy-Schwarz is true, well, for everything, all reals. Okay, is this clear to everyone? Cauchy-Schwarz is just for every positive reals, AIs and BIs, this inequality is true, and equality holds if these ratios are equal. Okay, very good. Now, I'll also cover another Cauchy-Schwarz. Usually, actually, when you'll see it, you won't see it in this form. I mean, okay, no, you will see it in this form, but like, there's one form of Cauchy-Schwarz that is like extremely useful, and in fact, it's like sometimes stated as its own result. It's called Titu's lemma. Okay, so I'll ask you to apply Cauchy-Schwarz on Titu's lemma is just for like a bunch of AIs and BIs that are angel form, sure, that are positive. The reason we need positive is will be clear. Apply Cauchy-Schwarz Condition false. There is no all real numbers. AI and BI can be any real numbers. So apply Cauchy-Schwarz on these things. So A1 by root B1, A2 by root B2. And this time for this inequality, since I'm taking roots, you require positives. Like these are our AIs and take these as our BIs. Just B1, B2, B3, and so on. B. Apply Cauchy-Schwarz on these and tell me what you get.
But AIs could be negative because we have
Yeah, okay. AIs can be negative. That is true. Usually, yeah, AIs can be negative. That's fine. Usually, like that. Yeah, AIs can be negative. It's usually like, I don't think, have I ever seen? Yeah, okay, that can happen. No problem. That's fine.
Nice.
Okay. BIs have to be positive, AI don't. So apply Cauchy-Schwarz. What do we get? So on one side you have this. This. Someone's mic is unmuted. Yes, you get this, what I have written, right? And now you divide by summation B1. So you can write this as A1 square by B1 plus A2 square by B2 plus dot 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 is greater than equal to A1 plus A2 plus dot 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 square by B1 plus B2 plus dot dot dot. This is the so-called T2's lemma. And equality holds. Okay. Is the statement of T2's lemma clear to everyone? Or like just the actually just is the proof also clear? Like what I said. Any questions? Yeah, so this is a very nice answer. Unreasonably useful. So let's use this on a problem. Try this. Also, if anyone has any questions so far, yeah, the BIs have to be in have to be positive reals or non-negative reals, but AIs don't. Okay, no, BIs have to be positive because you're dividing by them. You try this problem. Just give me a second. Be ending soon. Just okay. I think this will be the last problem that we'll do. I'll put some more Cauchy-Schwarz problem in the P set. What are you going to do after this? After this problem, I like take some questions like about anything. Like some people wanted to ask about IMO. It's fine. And after that, I'll like go. This is the basically the end of the session, I would say. What will you go and do? Like, bro wants to know my personal life, like have dinner or something. I don't know. Like you can if someone has like any questions after class, you can DM me. I'll respond in like some time. I might have like dinner and stuff. What will you have as dinner? भाई मुझे खुद नहीं पता. I don't know myself. Isn't it very late to have dinner? Nah, I have seen worse. Leave Aadish at home. And thank you. For dinner, actually, it's I might have golgappe. It's like if you really want to know. Oh, guys, problem. Non-spicy, sweet. I prefer sweet. Can you just show Titu's lemma? Okay, oh, screenshot. Okay, fine. I'll Titu's lemma. Go ahead, take a screenshot. Just put it, and then take a screenshot here, and take a screenshot here. Okay. Which university? Bhai? You bro wants to know my whole life. Guys, do the problem and then ask me whatever questions you want. Good.
IMO tips भैया.
Just do the question. Take right T2. Yes. Yes. Perfect. Someone has already. Okay, fine. I think people really want to ask questions. I'll just tell the answer. Okay, so as someone said, so this is just T2's lemma. So you have squares in the LHS, wait, where's my pen? So the LHS due to T2's lemma is greater than equal to, also notice since A, B, C, D, E are greater than 1, the denominators are indeed positive. Plus T plus E. Wait, we can wait if anyone is solving. Okay, sure. I'll wait. I'll wait. I'll wait. How many goals? Stop. I'll send you a number after I'm done eating. Um, But okay, we are definitely already over time. So okay, people who are trying okay, I guess look away for the screen for a second. I'll just tell the proof because I also like have to go. So by T2s, I'm from T square by minus 5. Okay. And so you have LHS greater than equal to this, right, by T2s. Now, I will take the denominator to be x. The numerator is then x plus 5 squared, which is equal to x plus 10 plus 25 by x. And apply AMGM on x and 25 by x. You'll get this is greater than equal to 10 plus 2 times. Okay, people who are listening, is this clear to everyone? People who want to try it. Okay, I have to, okay. Like I'll give you guys 5 minutes. You can ask any questions about, okay, ideally not what I'm gonna eat. I think, I think people have other questions they want to ask. You can ask, hey, I'm from Bangladesh. Can you give me advice so I can do good at IMO? Don't start by thinking like, I want to make IMO and like, I'll do good at IMO. Just whatever like stage you're preparing for, just try to prepare for it and have fun. Like honestly, just most important is actually just to have fun. I'm very serious about this. I never started like I want to try to make IMO. I was always like trying to have fun. I'm facing problems in functional equations, which entire book for functional equations. I mean, okay, book advice is like very weird to give, especially for algebra books. I have no idea. Like, use some handouts in your bio data soon, soon, soon. Like for functional equations, I mean, can you like follow a book? I can't really give you a book recommendations for algebra. That's resources are like once again for algebra, resources are like extremely weird. Like I personally, I have done like Evan handouts, but they are like a level higher than this. I don't know for like this level what should be good. I wonder like if just what excursion in mathematics has something. Struggling in algebra. Okay, all these questions, once again, struggling in algebra is a very difficult question to answer. Um, have you solved Cengage? No, no, I did not do Cengage. Do more algebra. I'll take more algebra. Do more yes. Actually, the only way to get better at algebra is do more algebra. Wait, are you asking? Is it Alex? Oh, yeah, I am graduated. I'm going to college. This equation. That's the worst explanations. Okay. Okay. Any other questions? I thought some people wanted to ask about IMO. How was your IMO through? Like, okay, 2 years will take like a long time to recap. Like, that like maybe in like OMC Discord VC somewhere, something I can answer in 5 minutes. I mean, I enjoyed it a lot. I would say that. But should we record this? Actually, I think I should stop recording at this point. But wait. Let me just stop sharing first. Won't you tell a story? Oh, there are stories, but you guys are kids. You should not be hearing the stories.